Deep sea methane seeps are areas where methane and other chemicals escape from the seafloor and fuel diverse communities. The research that we're conducting within the seep environments along the Cascadia margin is interdisciplinary in nature. We're focused on the physical environment, the chemistry, as well as the ecology within these seeps. And pulling together all of those different pieces will give us an understanding of what controls seeps here in the Pacific and how they may be influenced in other parts of the world.
We're following up on previous cruises that have been out here to map the seep, and now we have a chance to literally dig deeper into the dynamics of these seeps. Some of the main questions we're tackling as a team are, what kind of communities exist that use the methane and the sulfide? So what are they? Where are they? How do these communities differ from a seep at a shallow depth, 200 meters, versus a seep at 1,500 meters? Now we get to go down with ROV and a whole new suite of tools to try to understand the dynamic characteristics of these seeps.
What we have here is the bubble box, and the bubble box is designed to record bubble release from the seafloor. So the idea is that we put it on top of an actively bubbling seep, and there are two cameras looking 90 degrees to each other so that we get a stereographic image, so that we can see the size and the rising speed from two sides. So we actually use automated algorithms to get 3 axes of the bubble to calculate the volume.
So these are subsurface landers, and the primary objective of these is to take chemical measurements on the bottom of the ocean. We have a series of different sensors, from methane sensors, oxygen sensors, conductivity, temperature, pressure. They'll go up over the side, we'll drop them in, we'll track them going down using this system here, which is a USBL, and we'll be back here in about 3 days to check on it.
The gas brand is an hydroacoustical system. The main sensor of it is a multi-beam. So usually you use a multi-beam to do bathymetry on the ocean floor. But what we do with this multi-beam, we place it horizontally to the ocean floor, and it has an opening angle of 120 degrees. When the bubbles go through this beam, they will be detected, so they return a signal, and this gives us the chance to make long-term observations if there are different amount of bubbles during tide changes, for example.
The more we understand these environments here, gives us a window into understanding ocean health.